Thank you for watching this video. So in this video, I'm doing question 5 of November 2023, question paper mathematics paper 1. These are functions. So we have two functions, as you can see here. The blue one is the hyperbola G, and the pink one is the parabola F. So let's read the statement. Question 5 reads as follows. The graphs of F and G are drawn below. So here is F is the pink one, the parabola, and G is the blue one, the parabola, a hyperbola. So f of x have this equation. You are given the equation for f, and this is the equation for g. Okay. You can see that the equation for g is incomplete. So let's go. They're saying a point of intersection of f and g is B, the turning point of f. So you are told that at this point B, here at the turning point of f, so you can see this is the turning point, B is the turning point of f. These two functions intersect there, right? The graph of f have x-intercepts at -3 and 5, and the y-intercept at c. So you are told that your function f, the parabola, have the x-intercept there at -3 and at 5. Those are your x-intercepts. And the y-intercept is at c, as you can see over there. 5. We have analyzed our graph, so we can go straight to the questions. So we're going to 5.1. 5.1 read as follows. Write down the coordinates of the turning point of f. So they want you to write the coordinates of our turning point, which is those are the coordinates of b. So you are given the function, the equation of f to be -12 x minus 1 all squared plus 8, right? So this is the equation for a function f. So when you are given the equation of a parabola in this form, right? So if it is in this form, y is equal to a into x minus p all squared plus q. If you're given it in this form, this p and q are the coordinates of your turning point. So to find the coordinates here, so you say x minus p equated to 0, and solve for x. X is equal to p. This is the x coordinate. And the y coordinate is q. You take it as it is. So y is equal to q. So those two are the coordinates. So which means p and q are your coordinates. You only do this if you're given the equation of a parabola in this form. And if you look here, it's exactly in this form. So what you're going to do, you say, okay, my x minus 1 is equal to 0, which means my x coordinate of the turning point is at x equal to 1, right? Then the y coordinate, you take it as it is 8. So the coordinates of b, which are here. So what? X is 1 and b and y is 8. And if you look at it, so the first quadrant, both coordinates are positive. It makes sense to have those coordinates of b to be 1 and 8. So these are the coordinates. I hope this does make sense. We'll move on to 5.2. What are they saying in 5.2? Calculate the coordinates of C. So they want us to calculate the coordinates of C. What is C? C is this point here. You were told that y-intercept at C. So which means F, which is the parabola, have the y-intercept at C. What do you know about that y-intercept? You know that along this line x equal to 0, and along this horizontal line your y is equal to 0. That's what you know. So you know what the x coordinate is already there. X coordinate is 0 because anywhere along this line x is 0. So this is the x-axis. Sorry, the y-axis at the line x is equal to 0. So along this line, you know your x is always 0. So we're given the equation f of x to be equal to -12 x minus 1 all squared plus 8, right? So they want the coordinates, right, of C. So you already know that. So your coordinates of C are in the form x and y. So you already know that C is 0 and f of x, which is your y, is f of x. Or maybe let's say f at 0. F at 0. So you know your x-coordinate is what? Is 0. You need f at 0, which is the value of your function at 0. So what do we do? To find the value of your function at 0, say, okay, f at 0, this is equal to minus half of what? 0 minus 1 all squared, right, plus 8. So if you punch that, this is 1, this is minus half. So what is this? This is 7.5, this one here. The answer of this is 7.5. So the coordinates now of your C are what? As 0 and 7.5. These are the coordinates for C. Done with this one. Okay, so now we're doing 5.3. 5.3 read as follows. Calculate the value of D. What is D? D is this number here, right? So we have g of x is equal to d over x, right? What is this? This function is a hyperbola, right? We know hyperbola have a general formula a over x minus p plus q, right? Where p and q are your asymptotes. P is the vertical asymptote and q is the horizontal asymptote. So now, in our case, you can see that there's no q, right? And there is no p as well. So what does that mean? It means that your p is equal to 0 and your q is equal to 0. Which means your vertical asymptote is at x is equal to 0 here. And your horizontal is at y is equal to 0. This is the asymptote that you have. That's why it's like this. It's because p and q are 0. So you're only left with this over that. So your a in this case is d. That's what you have. So your asymptotes are that and that are there. So what do you have? So we said here g of x is equal to d over x. So we want the value of d. How can you find the value of d? We need at least one point on g. And substitute its y value there and its x value there. Then you can find the value of d. Do we have a point on g? Here is g. There's no point here, right? Here, we do have a point there because we know what the coordinates of b are. We said it's 1 and 8, right? So we're told that b is the turning point of f, right? And also you were told that is the point of intersection of g and f. So you're told that f and g. So you're told that f and g intersect at b. That's what they said. So now you know one point on g, which is b, and the coordinates 1 and 8. So your y is what? Your y is 8. So 8 is equal to d over x, and your x is what? Is 1. What does that mean? It means that your d is equal to 8. Therefore, g of x is equal to 8 divided by x, where your x must not be equal to 0 and your y must not be equal to 0, because that's where your horizontal and the vertical asymptotes are. So this one was pretty much straightforward. So we move to the next one, 5.4. So what are they saying at 5.4? Write down the range of g. So they want a range of g. What is g? So g is this thing here, right? So what is the range? So I will say in simple terms, range is the set of y values that your function is using, or your set of y values your function is allowed to use. Do you understand? So here, when I wrote the function here, I said the function is not allowed to use x. X is equal to 0, because that's where we have a vertical asymptote. And it's not allowed to use y is equal to 0, because that's where we have a horizontal asymptote. Because this graph of ours will not cross, g, the blue graph, will not cross the y-axis. it will also not cross or touch the x-axis. Same thing with the y-axis. So g will not touch your function. You have the horizontal asymptote here at y is equal to 0, right? And you have a vertical asymptote here at x is equal to 0. So this is the line x is equal to 0, and this is the line y is equal to 0. So this asymptote, this graph g, will not touch or cross the asymptote on that part, on this part, right? But it can use all the y values above here and or all the y values below here. But it's not allowed to cross this or touch this line y is equal to 0. So the only y value that is not allowed to use is y is equal to 0. But it seems like you can use all others, right? So in simple terms, your function will use all the y values above and all the y values below. But it will not touch the line y is equal to 0, because that's where the horizontal asymptote is. So your range now, you will say, okay, my y must be greater than 0, or my y must be less than 0. Because that's where my function is defined. Below y is equal to 0 and above y is equal to 0. Because you can see where y equal to 0 is. It's this horizontal line here. Or someone else will say it will use all y values, right? But it will not use y is equal to 0. This is the same thing. So we're done with 5.4 because you're only checking the y values that your function is allowed to use. It's only allowed to use the y values above or y values below. So your y should be greater than 0 or your y should be less than 0. Or one would write it as, oh, okay, it's the same thing, really. So these two are enough. We move to the next one, 5.5. I will clean the board and then do 5.5. Okay, so now we're doing 5.5. 5.5 read as follows. For which values of x will f of x times g of x be less or equal to 0? Right? So they're asking, what are the values of x when you multiply the y values of your f and your y at the same x value, will the product be less or equal to 0? So if you take maybe a y value here on this pink graph and the y value here on the blue one, and you multiply both of them, this y value is negative and this y value is negative. So the product that you will get, the answer will be positive, right? So if you take a y value here and there, right, they should be directly above each other. So if you take this y value and multiply that with that y value, the answer will be positive, which is not the situation that we're looking for. We want, when we multiply our y values, the product to be less or equal to 0. To obtain that condition, you need at least, actually, you need at least one of them to be 0. F or g of x to be 0, which means you need your y value of your g or f to be 0, right? And you need, that's when you will get the condition of the product being equal to 0, when at least one of them is 0, right? And then now, to obtain the second condition to be less, the product to be less or equal to 0, you need exactly one to be 0 and the other to be positive. So if you want the product to be equal to 0, you want at least one of your functions to have a y value that is 0. For example, look here. F here is 0, right? So at this point, you multiply that y value and the one directly below it, the product will be 0. And here, f of x is also 0 there, which is when you multiply this y value here, which is 0, and the one directly above it, which is maybe this one here, which will be 0. So here, you multiply these two y values, this one and that one. the product will be 0. Because you know f is 0, so 0 times any number, that number will be 0. Right? Which is good. So, to obtain the second condition, right, where the product is less than 0, you need exactly one function to be less than 0 and the other to be greater than 0. So you need one function to be positive and the other function to be negative. So in a case where f is positive, to get a product of f and g to be less than 0, you need your g to be negative and vice versa. So now to get the entire condition, look where your function is 0 and where other is above the x-axis, so the x-axis, and the other is below the x-axis at the same time. That's what you need. So we're going to look for that here, where one function is positive and the other is negative. That's what you need. Then if one function is negative and the other is positive, their product will be less than 0, which is what you want. If one function is less than 0, is equal to 0, then the product will be 0, which is what you're looking for. So let's look at our function. So you can see here, and here, both functions are below 0 here, right? So their product will be positive, which is what we're not looking for. So, as I've said, here, both of them are negative. They are both below 0. So the product of f and g at any points, any two y values that are directly above each other, their product will be less than 0, will be greater than 0, which is not the condition that we're looking for. The condition that we're looking for the product where it is less or equal to 0. Fine. So on this side of minus 3, which is on the left-hand side of minus 3, the product on the left-hand side of minus 3 will always be positive. Because if you multiply any two y values, they will be both negative. So the product will be positive. So here, but here, at x equal to minus 3, f of x is equal to 0 there, which means you know the y value of f is 0. The y value of g is less than 0. But the product of this and that, which is the product of this y value here at this dot and the y that is directly below it, it will be 0, which is the condition that we want, right? And also, if you move to the right-hand side of your minus 3, here's minus 3, if you move to the right-hand side of minus 3, up until 0, right, you will see that f is positive and g is negative. So if you take the product of any two y values that are directly above each other, their product will be less than 0, which is what we want. So at x is equal to minus 3, from x equal to minus 3, right, up until before 0, because we don't get to 0, up until before 0, right, the product of these two y values will be less or equal to 0, because we know at x equal to minus 3, the product is equal to 0. And then in between, the other will be positive, the other function will be negative, which is if you take any two y values that are directly above each other, their product will be less than 0. So, which means on this interval here, that's why you will get this condition satisfied. So what is this interval? It's x is from minus 3, right? I'm not sure if it's clear. From minus 3 to 0. 0, we don't get to 0, right? Before 0. So I said use the round bracket because we're not including 0. Why are we not including 0? As much as g is positive, right? So as much as f is positive at c, right? G is not defined at x is equal to 0 because we said at x equal to 0 we have a vertical asymptote. So we'll only take the x values where they are both defined, because how can we multiply that 7.5 that we have there? Because we said this was 7.5, right? Coordinates of C, 7.50 and 7.5. So this 7.5, what are we going to multiply with? What are we going to multiply this 7.5 with? Because there's no corresponding y value for G. So you will only multiply on the interval where they're both defined. You know that your G is not defined at x is equal to 0 because you have your vertical asymptote there. So in this area from -3 to there, the condition was satisfied because at -3, y was 0. So 0 times the y value directly below it is 0. And if you take any two y values that are directly above each other, their product will be less than 0, which is what you want. And then after 0, look after 0, both functions are positive because they are both above 0. Then now, if you get at 5, you'll see that at 5, f is 0 again at x equal to 5. So if you multiply this y is equal to 0 and that y value that is positive there, the product will be 0, which is what you want again. And after 5, which is on the right hand side of 5, you can see one will always be negative and the other will always be positive. So which means your product will also be satisfied on the right hand side of 5. So this is the situation that we want. So from 5 up to positive infinity, the product, if you take any two y values that are directly above each other, which is this one and directly below it, the product will always be less than 0, which is what you want. And at 5, this is where the product is exactly 0. So say this interval together with what? With 5 to positive infinity. One would say x greater or equal to -3 less than 0, or x should be greater or equal to 5. That's another way of writing it. Done. We move on to 5.6. What are they saying in 5.6? Calculate the values of k, right? So that h of x defined as -2x plus k will not intersect g. So we are given h of x to be -2x plus k, right? So they're asking for which values of x, for which values of k, right, will this function not intersect g? So you know that g of x is defined to be 8 over x, right? That is your g of x. This is your equation for g of x. So they're asking, what are the values of k, right? What should the values of k be so that h does not intersect g? That's what they're asking. What, for which values of k that should we have so that h and g do not intersect? That's what they're asking. So how do you deal with this? You say, okay, h of x, if h of x and your g of x do not intersect, right? Then h of x equal g of x have no real solutions. This is what this thing means. It means that if you equate these two equations, you won't have a real solution because they don't intersect. So if you equate this and that, you should not be able to solve that equation, right? Because having solutions, which is real solutions, it means that they intersect, but these should have no solutions. So let's equate these two, knowing that these two will not intersect, right? And try to investigate what will those conditions be such that these two do not intersect. So we know that h of x equal to g of x have no real solutions. We know that because we want these two not to intersect, right? So now we know that we have minus 2x plus k is equal to 8 over x, right? Multiplied throughout by x, minus 2x squared plus xk, or plus kx is equal to 8, right? So 0 is equal to 2x squared minus kx plus 8 is equal to 0. So we have a quadratic equation here, right? We have this quadratic equation, and we know that this quadratic equation, is coming from equating these two. We were trying to solve this. We equated these two and attempted to solve them, but you know that this equation have no real roots. What does that mean for a quadratic equation? If a quadratic equation have no real roots, right? What does that mean? It means that the discriminant, right, is less than 0. Do you understand? So you know that to solve the quadratic equation, you can use a quadratic formula, right? You can say x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. You use this. This is what you use. Then this part is a discriminant. So b squared minus 4ac is the discriminant. It's the formula of a discriminant. When I talk about discriminant, I talk about this part that is under the square root here. That is your discriminant. So now, you know that this have no solutions. Do you understand? If this thing has no solutions, it means that that part over there, the square root of the discriminant, is not defined. Right? You know that square root is defined. So square root of a is a real number, which means defined if a is greater or equal to 0. Which means if this a here is a positive number, or sorry, is a non-negative number, then this square root will be defined if a is non-negative. But then if square root of a is non-real, if your a is less than 0, which means if your a is a negative number like negative 2, the square root of negative 2 is undefined. Right? So this thing, now you have a non-real number there. So now, coming back to this. So your formula in simple terms is x is equal to negative b plus or minus square root of a discriminant all over 2a. Do you understand? For this, you know that your a there is 2, right? So you won't have a problem. And your b is k, negative k, which is that. So the only condition now that will make the solution not to be real, or which means to have problems finding the solutions, is if this thing is less than 0. If that part under the square root is less than 0, now you have this situation here. Then your number, your answer there will be non-real. But now we know that these two do not intersect. So they have non-real solution. Which means if we put them in a quadratic, to obtain that non-real solution, this part under the square root, the discriminant, should be less than 0, which is what I said there. But if it had real solutions, the part under the square root was going to be greater or equal to 0. And equal to 0 if the roots are equal, both of your roots are the same. And greater than 0 if your roots are distinct, which is different. So in this case, we know that this solution, this equation, have no real solutions. What does that mean? It means the discriminant is 0, is less than 0. No, the discriminant is less than 0. So which means we know that this part under the square root your discriminant is less than 0. And your discriminant is equal to b squared minus 4ac less than 0. What is your b? Your b is negative k, and your negative k all squared minus 4 into a. What is your a? Your a is 2. What is c? Your c is 8. Is less than 0. This is what we have. So we have k squared minus 64 less than 0. So we have, this is more like question 1. So what do you do here? You find critical values from here. So I'm going to clean this part of 5.5. Hopefully I will finish, I will have enough space. But from those critical values, you can say k squared minus 64 is equal to 0. Because we want the critical values. I'll clean this part of 5.5. So what do you have? You have that k squared minus 64 is equal to k plus 64, or k plus 8. K minus 8 is equal to 0, which means your k is equal to 8, or your k is equal to minus 8. Right? And if you were to draw it, and have your k-axis here, you have your minus 8 and you have a positive 8. So your function would look, actually, yeah, would look more like this. Right? So you want where your function is what? Where your function is less than 0. Right? Where is it less than 0? It's below 0 here. At that point, it is equal to 0 there. And here is equal to 0. So it should be below 0 here. What are the x values? Is these x values between minus 8 and 8. So your values are k should be between minus 8 and 8. Or 1, say k should be less than 8, greater than minus 8. So that should be a solution. Just use nature of fruits here. And I hope it is clear. And I try to explain it. So we're left with one question, which is 5.7. I'll clean the board and write 5.7. Cheers. So now we're doing 5.7, right? 5.7 reads as follows. H is a tangent to G at R, a point in the first quadrant. Calculate the value of t such that a function defined by y is equal to f of x plus t intersect G at R. Let me read this again. They're saying H, which is this, is a tangent to G at a point R, which lies in the first quadrant. So they're saying calculate t such that a function defined by y is equal to f of x plus t intersects G at a point R. So I think I'll need different ink. Let me find a different color, which I think I do have. Okay, so you are told that this equation h of x, which is this, right? You are told now that it is a tangent to G. Let's say G maybe is a point here, right? So I'll draw the tangent. This is H. I wanted to use a different color to draw H, but I forgot. So this is your H here, and it's a tangent to this point here. This point is R, right? So they define, so you're told that H, which is defined as that, is a tangent at R, which is the point on G, and the tangent on the first quadrant, right? So they define another function, y is called f of x plus t, right? That's saying this function of yours intersects They're saying this intercept function of yours intersect G at this point R. So if you look at this, you have y is equal to f of x plus t, right? You know that t is a real number, right? So if you add a real number on this function f of x, what does it do? If, for example, let's think of any real number 2, right? Let's say you say plus 2 after 8 here. This will become 8, 10, right? So what it will do, it will shift your function 2 units upwards, right? So your turning point will be at 1 and 10 now, if you shift this function 2 units up. Do you understand? If your t is minus 2, so you add minus 2 there, which means you're adding minus 2 on this one, because this is f here. So whatever that you're adding there at f of x, you are adding it on this equation. If you add minus 2 here, the answer will be 6, which means you're shifting this thing 2 units down. So what these people are asking you essentially, how many times should they shift f down, right? Such that your f passes through this point here. So they want your f to look like something like this maybe. So they want your f, doesn't look very nice. They want your f to behave more or less like this, to move from there to there. They're asking how many units should you shift G downwards so that it goes down to that. Those number of units are your value of what? Of t. That's how I looked at it. It's like they're asking how many units should they drag G down so that it sits exactly here, or it crosses there, the point at R. That's what they're asking you. So they want you to find. They're asking you how many times, or what is the distance between these two? Because whatever that distance is, you will add the negative of it to f so that it goes down. That's what they're asking. So how do we do this? So we can say, okay, we know, what do we know? We know that at this point here, right, f of x intersect with h of x, which is your tangent. The tangent, f of x and g of x do intersect. What do they intersect? They intersect, because your tangent is h is black here, right? And then your g is, actually, I'm trying to say, your g of x intersects your h of x, your tangent, which is this tangent h here, intersects with g. That's what we know, right? Which means there is a solution. There is a real solution now, because if h of x is now a tangent to our function, which means they do intersect, right? Or they do touch. So they do touch. So there is a solution. We do have a real solution now. So which means if we equate these two, we have real solutions. Because we know that your h of h touches this one. So at least at that point, they will have the same coordinates. That's what we know. Is that since they are meeting, these h and g are meeting there, there is a solution. It's the point of intersection. They intersect. They have the same coordinates. So this will have real solutions. So what do? We try to find those real solutions. So what do? Or maybe, well, actually, we're not trying to find the real solutions. We're trying to find where are these two functions meeting. We want the coordinates of where they meet, right? Once you get the coordinates of where these two functions meet, which is where the tangent touches your g, you will be able to find the y value of g here and the y value of f there. Then you will know what that distance is. Then you know how many times this point should be pulled down so that it crosses here. Or what you can find the coordinates of R, right? Then now you say, okay, my new function defined is that I know its x and y value, right? And I know its x value. So what should be the value of t? It should be much easier because, yeah, I'll do it like that. It will be straightforward that way. So what do we do next? So we say, okay, we know g of x is 8 over x is equal to minus 2x plus k, right? Multiply throughout by x, so 8 is equal to minus 2x squared plus kx. Then you transpose this to the left-hand side. We have, I should be 2x squared here. We have 2x squared minus kx plus 8 is equal to 0. So this thing, they touch, right? The tangent touches G. So we know that this will have real solutions. So in this case, we will have what? Real solutions. Because these two things are touching, which means you will be able to find what, for that value of, for some value of k, you will be able to find the point of intersection. Right? You will be able to find, for whatever value of k that you are given, if they are touching, you will be able to find the real solutions. That's what this thing means. So, how many times are these two graphs meeting? They're meeting twice, right? They're meeting twice. So you have two roots, two real roots. And these roots of yours, since these two are just touching, so they are equal, these roots will be equal. So I can't tell on the rationality or irrationality of them. So which means, if we take this equation and substitute on our quadratic equation, x equal to negative b plus or minus square root of b squared minus 4ac all over 2a here. This is the nature of roots, basics. So if you have two roots, right, and they are equal, right, what does that mean? It means your discriminant is equal to 0, which is this part under the square root should be 0. Because if the part under the square root is 0, right, you will have only two solutions. You will have x is equal to negative b plus square root of 0 over 2a, or you will have, what else will you have? X is equal to negative b minus square root of 0 over 2a. These are the two possible solutions. Because if the roots are equal, they will only, these two solutions will only be equal if this part is 0, because now you will be adding 0 and subtracting 0. Because look, you have negative b plus square root of 0 over 2a. It is equal to negative b minus square root of 0 plus 2a. These two solutions are only equal if the part under the square root, which is a discriminant, is 0. So you need your discriminant to be 0. That's what you need. You need the discriminant to be 0. How will your discriminant be 0? So now, you will ask yourself questions. What should the value of k be such that my discriminant is 0? So you know discriminant is what? B squared minus 4ac, right? 0 is equal to, what is b? Negative k all squared minus 4a. What is your a? Your a is 2. And your c is what? Your c is 8. So you have 0 is equal to k squared minus 64. So 0 is equal to k 8 plus minus. So your k is equal to plus or minus 8. So your k should be plus or minus 8. What is k? So your k should be plus 8 or your k should be minus 8. What is k? K is the y-intercept of your tangent. Where is your tangent? Your tangent is here, right? It's here. So if your tangent is this one here, and it will cross some up there. So there's no way that this point, this y-intercept of yours, because your k is the y-intercept there. So there's no way that this y-intercept of yours is negative. So you should take the positive value of k. This one. This is a positive value of k. So you know what k is, right? So k is that. So now, we need to find now, where are these two functions of ours meeting? The x value, where they intersect. We said the solution is that. We said the solution is what? X equal to negative b over 2a. Actually, it is just this. X is equal to negative b over 2a, because this and that are exactly the same. Those are the roots. So what do we do from here? We say, okay, now, x is equal to negative b over 2a. So what is our b? Our b is negative k, right? So which means our equation here is this one. So we have 2x squared minus k, which is 8x plus 8 is equal to 0. This is the equation that we have here, right? So now we want to find our roots now for this equation, and we said they will be given by that. So our roots will be what? Actually, yeah, so we want our roots for this equation, right? So you know how to solve this equation, really. You can say what, you can use this, really. Or it's up to you. So divide by 2, divide by 2, divide by 2, divide by 2. So x squared minus 4x plus 4 is equal to 0. Really? So what do you have? You have x minus 4 minus 2 actually, all squared is equal to 0. Therefore, your x is equal to 2. So you will have a tangent at x is equal to 2. That is where you will have a tangent. You will have a tangent at x equal to 2. What will be the y value there? You can find the y value because you know that h of x is equal to minus 2x plus 8. So h at 2 will be equal to what? Your h at 2 is equal to minus 2, right? Your h at 2 is equal to minus 2 into 2 plus 8. So you get that your h at 2 is equal to, this is minus 4, so you have 4. So your coordinates at r of r are 2 and 4. These are your coordinates of r. These are your coordinates of r. So which means this is where this function is crossing. It's crossing. You want this function, this newly defined function, to go past that point, right? So if you want this new function of yours to go past that point, I will clean up here because I don't think we will need this. You want this newly defined function of yours to go past that point, right? So you want it to, you know that your newly defined function is y is equal to minus half to x minus 1 all squared plus 8 plus t. So you want to find the value of t. You are told that, or you know that this function go past this point, right? So what is the y? The y is 4. So 4 is equal to minus half of x. What is the value of x? 2 minus 1 all squared plus 8, right? Plus 8 plus t. You want the value of t. So we have 4 is equal to, we did have this thing here. So it was 7.5 plus t. So transpose the t is equal to minus 3.5. So this is the value of t. That is the value of t. So which means in order to move this graph here to here, you must move it 3.5 units down. That's what you need to do. Or 1, since you have the coordinates of r to be that, which you have the coordinates of this point here, you can find what the coordinates of this point will be, which means find your f at 2, right? Your f at 2 will be your f at your f at 2, what is it? It's 7.5, right? Your f at 2 is 7.5. So now you know that here, the y value here is 7.5, and the y value here is, what is it? It's 4. Then what's the difference here? It's 3.5 units. It's like 5, 6, 7.5. So it's 3.5 units. So you know that this you should push it down 7 units, which means if you want to move your original function from there to this point, you must add negative 3.5 units down. That's what you need. That's how you find the value of t. So you can do it doing nature of roots. But the easiest way is calculus. But the reason I took this one here, I took this one because I'm assuming that when you're watching this video, or maybe a grade 12 watching this video, might not have covered calculus when they're doing this. But they should know nature of roots from grade 11. So this is how to do it. And if you think it's very long or very difficult when you know your calculus, I'm sure you can find some other videos on the internet that will make it much simpler. But this is the way I learned it. Otherwise, thank you for watching.